Okay, so as we said, we're going to start with the measurement section. We've got 6 lessons on this, and we are going to be talking about conversions, and specifically today we're going to talk about the imperial to metric conversion or metric to imperial conversion. All right, and I've got a little question here, but why? Why do we do this? Why is this even in the syllabus, imperial to metric? Okay, so I wanted to show you this map. I don't know if you can see it. This is a map about who uses the imperial and who uses the metric system. Now, the blue are all the people that use the metric system. All right, that's us. So we just like everyone else in the world. We use the metric system. It's a good system. It works. But we have these people in the US and Canada, and nothing wrong with the US and Canada, but those people in Myanmar and Liberia, those little countries, they decided to use the imperial system for whatever reason. We don't know what the reason is, but they decided to do it. And because of that, if we want to trade or communicate or talk about different sizes and dimensions and different objects, and they are mentioning one system and we are mentioning the other, then we have to know how to convert between the two. So in math literacy, we discuss this. It's used very often. Even in matric exams, we have these kind of questions, how to convert between the imperial and the metric system. We're going to go into more detail with the metric system in another lesson, probably next week. And that's going to go into detail into how to convert within the metric system. And we're going to talk about that a bit later. But today, excuse me, we're just going to talk about converting between the metric and the imperial system. Okay, what is good to know for all of us doing math literacy is that when we, in an exam, when we have a question where the question's given in one system and we have to convert to the other, they have to provide a formula for you, okay? You are not expected to know and memorize the conversions from the one system to the other, metric to imperial or vice versa. They give us the conversion formula, which is very good to know. That's the good news, okay? So if they're going to ask you to convert from one to the other between these two systems, they have to give you the formula. When you work within the metric system, though, you have to know how to convert within that single system. But between these two, they have to give you the formula in the exam. So you'll see in the questions that we do, I will always provide you with the formula when we do these questions. Okay, so here's an example. All right, there's an example there. You are given the conversion formula. All right, there it is there. This first line, they often say given or use the following formula in the exam, but there's the conversion formula for you. And now you have to know the units for each system. So we all know the metric system unit for meters is M, and here's the imperial system units for feet, which is FT. And you'll see when I write the questions, I write the word, and I also write the units for the unit that we're going to use. So for feet, I will write the in brackets FT, so you guys can start to learn the symbols for each of these systems. Okay, so when we get a question, when we're talking about imperial to metric, we are always given the formula, which is good news. Okay, so let's have a look at these two questions here. Let's see how we do them. We are given that 1 meter is equal to 3,28 feet. All right, now let's think about that in our minds. 1 meter, if we take a line that goes across and that is 1 meter. One of those meters gives me 3,28 feet. So it gives me 3 feet and a little bit. Okay, so in your mind, you can partition this meter up into feet. There's 3 partitions with a little space left over at the end there. So you can picture it in your head. And when you have a picture in your mind, it helps you to understand the question as well. So 1 meter gives us 3 imperial feet plus a little piece that's left over there. Okay, so if I, for example, said I wanted to convert 2 meters if you understand this already, that 1 meter is 3 feet and a little bit, if I say to you, what is 2 meters? Well, then you know you're just going to double these partitions here. So it's going to be something around 6 and a little bit. Okay. So if you have an understanding of the relationship between the two systems in your head, then it helps you to answer these questions a little bit easier. Okay. So now question, 1 meter is equal to 3,28 feet. All right. And a foot in the imperial system is about, I don't know if you can see, but it's about 30 centimeters. So those rulers that you use in class, that's a 30 centimeter ruler, that is roughly 1 foot. Okay, so think about 1 foot, imperial foot is about a 30 centimeter ruler. Okay, and they're asking us in this question to convert 3 meters into feet. Okay, so we're going from meters into feet. Okay, who can tell me what mathematical operation we are going to do to change our 3 meters into feet? In chat, can you type in there which mathematical operator, plus, minus, times, divide, are we going to use to convert our meters into feet? All right, Kashlecha, well done. Times, very good. X, there we go, that's times. Well done, Secho. X again, very good, Ayanda, thank you, well done. Okay, so you guys have the right idea. We're going to multiply. Okay, very good, thanks guys, good answer. So our 3 meters, we're going to use that and take our feet and make them more. Okay. Now, another way to think of it is like this. There's a relationship between the meters and the feet. And I want you to think, when I say the word relationship, we can often use the word ratio to explain that relationship. But let's not even get that fancy. Let's just do, say, 1 meter has a relationship with 3,28 feet. All right, so that's the relationship. When you have 1 meter, you always have 3,28 feet. Now, if we want to change the 1 meter into 3 meters, what are we doing to that 1 meter to change it into 3? We have to multiply that by 3. So what you do on the left-hand side over here to change the 1 meter into 3 meters, you can also do on the right-hand side here. You do the same thing. Okay, so how does our 3,28 multiplied by 3, what does that look like? So here's my calculator. So I'm just going to say 3.28, and I'm going to multiply by 3. And our answer, let's change it into decimal form, is 9,84. Okay, so if we multiply 3,28, we're going to get 9,84. All right, so 9,84 feet. Okay, so you see that we had to change the meters by 3 to become 3 meters. So we changed the feet by 3, and that gives us 9,84 meters. All right, so that's one way to look at it, is that if you're changing the one side of the relationship, you've got to change the other side as well. So now, doing this calculation in the test or exam, you can show it this way, but the best way to show it in the test or exam, I'm going to say here the answer for question 1 is taking your 3 meters and just multiplying it by taking your 3 feet, 3,28 feet, and multiplying it by 3. All right, and this will give us 9,84 feet. Now, look at the answer here. Our answer has got decimals, and when I did the calculation on my calculator, it only showed me 2 decimals, which is useful because in math literacy, you should always round off to 2 decimal places unless they tell you otherwise. Okay, so only round off to 2 decimal places unless they tell you otherwise. So 2 decimals is good. If we have decimals in our answer, that's fine. I'm only showing the 2. I was only given 2. I'm only going to show 2. Okay. All right. Let's move on to this second question here. Very soon, you guys are going to do a couple of these on your own. Should be quite easy. Let's have a look at question 2. The answer for question 2, I need to convert 19 feet into meters. All right. Now, how does this change things? 19 feet need to become meters. Well, if I use this way of looking at it, I'm going to show this method a couple of times, and then I'm going to just use the normal calculation. If I have if I have 1 meter, and that has a relationship with feet, and that it gives me 3,28 feet, and I have 19 feet over here, all right, what could I do to the 19 feet to get to 3,8 feet? How could I find that? Does anyone know in chat? How can I see, what must I do to this 19 to get back to 3,8? All right, what could I do to get back to 3,8? I'd have to divide. Very good. Don't forget your units. Yes, don't forget units. Division. That's right. I need to divide by a number. All right, very good. What is that number? Okay, to find that number, I can say 19 divided by 3,28. And it gives me this number here. Whoa, it's a long number. All right, 5.7926829. It's got lots of decimals. Okay, that's fine. I'm going to write some of those decimals out. So 5.79268. 5.79268. I have to remember that. So 5.79268. All right. So from 3,28 to get to 19, I'd have to multiply, all right, by this. I'd have to multiply by 5.79268 to get to 19. Okay, so just remember that. All right. So now when I get to my question and say convert 19 into meters, all right, just like you guys said, I have to divide. Okay, so I'm going to divide that. So I'm going to take my 19, let's do it down here. I'm going to say 19 divided by 3,28, and let's see what we get. All right, same number. Okay, so if you had 3,28 and you times it by 5.79268, you get back to 19 again. Okay, so to go from 19 back to 3,28, you divide by 3,28. All right, another way to look at this, let me write the answer down quickly, and I have to remember the decimals. Let's say 19 divided by 3.28 is 5.79268. All right, now we need to round off to 2 decimal places. So we're going to look at the second decimal, which is a 9. Will it change? Look at the number to the right of it. It's a 2. That's below 5. It's not going to change. So we're going to leave this as 5.79. And don't forget the units, meters. All right. Another way to look at the sum, okay, let me just run this out quickly, is to say, if I know that there are 3,28 feet for every meter is 3,28 feet, and then I want to know how many meters are in my 19 feet, then I'm going to ask myself, how many 3,28s are there in 19? Because each one of those is 1 meter. So how many 3,28s are there in 19? To find out how many 3,28s there are in 19, we just divide by 3,28 and we get this answer here. Okay. All right. So there's a couple of ways we can look at it. The most difficult part of this is when to times and when to divide. All right. But if you understand the relationship between the two, you will understand when you need to times and when you need to divide. So when if we're given that 1 meter is a certain value, and we're going from meters to that value in feet, we multiplied. If we're given 1 meter is a certain value of feet, and we're going from feet back to meters, then we had to divide. Okay. All right, that's enough of me talking. It's your time to shine. Okay, here are 2 questions for you. Shouldn't take you long. These are roughly 2 marks each in a normal test or exam. So 2 marks each, 4 marks worth. You guys should be able to do it in 4 or 5 minutes. So it's 25 minutes past 6 now. So at 6:30, we're going to come back and we're going to ask you to tell us your answers for question 1 and question 2. All right, so off you go. You guys are going to do these. Get your pen and paper and your calculator. You're going to do these 2 questions. And then we're going to come back at 6:30 and we're going to have a look at the answers. Off you go. Hope you guys are doing well. Hope you're remembering what we said. Let's see how it goes. Yes, guys, please put your answers in chat when you have them. If you have them already, you can start putting them into chat. We're going to have a look at them as they come through.
I feel like Katleho is going to drop her answer any minute now, but no pressure.
Katleho on fire tonight.
100%.
All right, let's see. We'll see who comes with the answers first.
And guys, also don't forget your units. They are very, very important.
Yes, with measurement, you always have to show your units. If you're converting from one unit to the other, you've got to show the marker which unit you are putting your answer in. Your result has to be in the same unit that they're looking at. All right, Ayanda.
She took the lead. Ayanda took the lead.
Okay, well done, Sine. And there's
there comes
with both of them. There we go. All right, Senior, well done. There's your second one. Well done, Lila.
You guys are stars. Look at Tiamo coming in with the units. So proud of you.
LBs, yes. LBS is the units for pounds. Very strange way of saying pounds. Whole imperial system is strange, if you ask me. I don't know why those countries are hanging on to it, but they do. And because of that, we are doing this today.
Look at all these great answers coming in.
Incredible. Well done.
They didn't even use the full 5 minutes.
Oh no, they're too quick. We're going to have to make it harder. Looks like these guys need more of a challenge.
More brilliant answers are coming in with units.
All right, looks like you guys are on the money. Okay, well done, guys. Looks like you are on the money. Oh, Lindsay. Okay, you try my best, my girl. Try your best to, why is it times in the first one, but division in the second one? Okay. So in the first one, when we're going from our 1 kilogram into 2.2, we are making our kilograms bigger by 2.2. So we're going to multiply because we're making them bigger. Okay, so if 1 kilogram is 2.2 and we're making our kilograms bigger, then our final answer, our pounds, must also be bigger. So we're going to multiply. But in the second question, our pounds, we're going to chop that 7.35 pounds up into 2.205 pieces. And that means it's going to get smaller. We chop it up. So we're going to divide by 2.205 and we're going to get 3.3. Okay, so when we increase it, we're going to times. And when we decrease it, we chop it up, we're going to divide. Okay, please also note that if the question asked for pounds, you must make sure that you give your answer in pounds. If the question wants kilograms over here, you must make sure that your answer is in kilograms. Please, like Kia said, make sure that your units are in your answer. Okay, well done, guys. Very impressed. You guys are very well. All right, let's move on. Let's see what other conversions we have. Okay, now we're talking about temperature today. All right, what about the measurement of temperature? All right, now you must be thinking, surely temperature is not involved in this battle between metric and imperial, but unfortunately it is. Okay, those countries that use the imperial system have their own way of measuring temperature. Okay, we're going to learn about that now. So we need, again, between the two systems, the metric and imperial way of measuring temperature, we need a conversion. We need a conversion formula. They have to give it to us in the exam. We can't answer the question because we're not supposed to know all the conversions between the two, or all the ratios between the two. They have to give it to us. Okay. Now, the conversion formula for the change between imperial and metric in terms of temperature is a little bit more complicated than what you've seen before. All right. But they have to give you this formula. So, for example, we're going to do a conversion where we take Fahrenheit. That's the imperial system's way of measuring temperature. They measure in Fahrenheit. And we're going to take Fahrenheit values and we're going to convert them to degrees Celsius, which is our way, because we want to talk about degrees Celsius. Okay. Now, this is the formula that you need to do this. You don't have to remember this. It gets given to you in the exam. They have to give it to you. Okay. What you do need to know is how to use it. Okay. So if you get given this formula, there is a clue here on what they're asking. Okay. So over here, we have degrees Celsius on the left-hand side. Okay. That's going to be where our answer comes out. All right. So our solution is going to be in degrees Celsius. But to get to the degrees Celsius, we need to put in Fahrenheit. And where do we put Fahrenheit, the value for Fahrenheit in? This is the place in the formula. So you see that F, capital F, with a little degree symbol, that's the Fahrenheit symbol. So that's where we're going to put our Fahrenheit value. Okay, so we're going to put the Fahrenheit value in here, and we're going to get our answer for degrees Celsius out over here. Okay, and we don't have to, in matric, you really don't need to learn how to manipulate equations. And no, this is not algebra and core maths. We don't have to worry about too many variables. But the skill of changing an equation around to suit your needs will come later on in matric. For now, you get given the formula, you put your values in, and you get your answer out. Okay, so in this question, it looks like they want us to work out degrees Celsius. They might give us a Fahrenheit value, but let's see. All right, here we go. Here's the question. If they give us the formula that degrees Celsius is Fahrenheit degrees minus 32 divided by 1,8, then convert 140 degrees Fahrenheit into degrees Celsius. Okay. Now, one thing I want to bring to your attention here in this formula is the brackets. Okay. So there are brackets here. the formula is not written out like this. Okay, that would give you a different answer. All right, so the brackets here are actually very important. Can someone in chat tell me, what does it mean in this formula? What do these brackets mean in this formula? What are they asking you to do? Anyone in chat, what can you tell me these brackets are asking you to do? If you see those brackets, what should you remember to do compared to if there weren't brackets? All right, good. Ayana, start with it. Good. Brackets together. Yes, if you put brackets together next to something, it does mean multiplication. Subtract the number inside. So Leela's saying go inside and do the subtraction first. Subtract. Good. Salome, very good. So we must do the subtraction part first. Okay, very good. Subtract. Subtract. Yes, we need to do the subtraction first. Okay, so if these brackets weren't here, we'd have to treat this formula pretty much the same way, because we'd take degrees Fahrenheit minus the 32 and then divide by 1.8. In fact, that's not correct, because BODMAS says, what? You need to do division first, don't you? So you should be doing the minus 32 divided by 1.8, okay? And if they had the brackets over here, we would have to focus on that first as well. So brackets indicate what you should be doing first, and you should follow BODMAS, which says B in BODMAS is for brackets. The O actually stands for powers. Okay, and then D for division. All right, so you do the brackets first. If there are any exponents, you go and do that then. And then after that, you go and do division. All right, so our order of operations is very important when we have lots of different operations and symbols in our formula here. Okay, so in our formula they gave us, we're going to take the degrees Fahrenheit and we're going to subtract 32 and take that answer and divide it by 1,8. Okay, so here is my solution. All right, now let's see how this works on the calculator. You can see here that we did 140, and there should be degrees there. Let's put a little symbol because that's the temperature reading. So 140 degrees went in here. That's where it went in, and out will come our answer over here. All right. So you see 140 goes into the formula there, and when you do all that in the calculator, you'll get an answer of 60 degrees Celsius. All right. So let's see how that looks on the calculator. Okay. Now, there's two ways you can do this. You can write it out on the calculator exactly like it is written on the page there. Okay, I'm going to use my brackets and I'm going to say divide by 1.8. Okay, we should get the same answer of 60 degrees. Okay, or what you guys often do, and I've seen this in classes as well, is some guys will do 140 minus 32. And then they'll press equals 108, and then they'll divide by 1.8 and then press equals again, and you still get the same answer. So sometimes it helps to do little pieces of the formula on your calculator. If you don't want to write the whole thing out, if it's very complicated, you don't want to write the whole thing out, that's fine. Just remember which part to do first. Okay. Now, writing out the whole formula on the calculator is actually very useful, because if you make a mistake, so let's say I put in 145 minus 32. Okay, so let's say I was in a rush, I was nervous in the exam, and I put in 145 there. Okay, and then I look and say, oh no, this is not correct. I can go back and change that and make it 140 before I get the answer. Or if I looked at my answer, let's say I made a mistake somewhere and I said multiply. Okay, let's say, or even minus. All right. And then I hit the answer over here and I look at it, 106. That doesn't really look right, because degrees Celsius should be quite a lot less than degrees Fahrenheit. Then you can go back into your calculator and check, oh, okay, that's where I made the mistake. That should have been division. Okay, so sometimes it helps to write the whole formula out in the calculator, and then you can change little bits and pieces if you want to, especially if you want to test something. If you write the whole formula out, then you can go back and change little bits and pieces. But you can do the calculation piece by piece. Just be very careful how you do it. Make sure you're doing the right thing first. Okay, so our answer here is 60 degrees Celsius, remembering the units. Okay. All right. Let's see. How are we doing, guys? How are you finding this so far? Does everyone understand so far? Makes sense? All right, let's test you guys. Let's see. I'm going to ask a very difficult question after this example, but I want you to try.
Dale.
Yes, sir. Yes, ma'am.
Mpo just would like you to re-explain.
Yes, yes. I'm going to do that right now.
Okay.
Okay. So, Paul, given the formula over here, they have to give you this formula. First things first, we need to know where to put the degrees Fahrenheit in, because they say take degrees Fahrenheit and convert it into degrees Celsius. So our Fahrenheit needs to become degrees Celsius, but where do we put the degrees Fahrenheit? Okay, so there's the symbol there in the question. Often they do give it to you in the question, but you need to know that degrees Fahrenheit, the symbol for it, Fahrenheit, is over there in the formula. So that's where we need to put our 140. Okay, so we're going to write this part. I'll write the whole formula out first, and then I'll put in the values that we need. Don't forget the brackets. Okay, so that is the formula. And now I'm going to put in my degrees Fahrenheit. My degrees Fahrenheit from the question are 140 degrees Fahrenheit. And then I'm going to minus 32, close the brackets, and divide by 1,8. Okay, then you go to your calculator and you can type it in exactly like you see it. So 140 minus 32 divide by 1.8. Hit enter. And yes, it should give us 60 degrees Celsius. All right. Okay. Now, I'm going to do a quick example here. All I'm going to do is ask you to say, what is 225 degrees Fahrenheit in degrees Celsius? All right, let's see in the chat who can give us the answer for 225 degrees Fahrenheit, converting it to degrees Celsius. So 225 degrees Fahrenheit, use that formula and convert it for me into degrees Celsius. All right, shouldn't take too long. 107,22, Ayanda, well done. 1,7,22. All right, it's pretty hard to put the degree symbol on a phone. I'm sure you guys are meaning to put in your units. It's not easy. There we go. Well done, Leela. Wow, that's perfect. All right, don't forget your
answers
units.
are fire.
Yes, these guys are quick. Very, very quick. Maybe it's because it's so hot today. They've all warmed up.
They can relate to the heat.
Yes. All right. 107,22 degrees. All right. Very good, guys. Very good. Very good. Very good. Well done. Thanks, Lindsay, for the units. All right. Let's check it out. Okay. So if there were two questions, and we've done the first one already, my calculator, well done. Thanks, guys. Thanks, Nonjabula. All right. My calculator still has my formula on it. So I don't have to retype the formula. All I have to do is go into my calculator and change the 140 degrees Fahrenheit to 225 degrees Fahrenheit and press equals. All right. Okay, quite a long decimal. It's a recurring decimal. We want 2 decimal places. The second decimal is a 2. The number to the right of it is smaller than 5, so it's not going to change it. So it's correct. Well done, guys. 107.22 degrees Fahrenheit. Okay, well done. I'm not going to do the calculation. I'm just going to write the answer here. 107.22 degrees Celsius. Don't forget the units. Well done. Exceptional. Okay. Now, here comes the challenge. Let's see. What I want to know, and I want someone to unmute and to speak to me and explain this to me. What if they also gave you a question like this? Convert 30 degrees Celsius into degrees Fahrenheit. And what if this was the only formula they gave you? Now, usually they will give you a new formula, but I want to see if you guys are smart enough. And how would you deal with this? What would you do? If you know that degrees Fahrenheit, you subtract, Sambu, unmute yourself, my boy. Take yourself off mute. Explain to me. Talk to me, Sambu. Sambu, you there? Don't be shy. Okay, I don't know if you can hear him, but I can't hear him.
I can't hear him either, and I asked him to unmute.
Okay. Is there anyone else? Anyone else can tell me, what if they gave us 30 degrees and we had to go to Fahrenheit, but they only gave us this formula?
I see Kamo has an answer in the chat. Do you perhaps want to tell us how you got the answer, Kamo?
Kamo, do you want to unmute and talk to us?
You times it by 1,8, and then you
Yes.
bring it by the comma up, by the brackets, then you add it by
Yes.
82.
Very
Then you
good.
get your answer.
Very good. So let's write what Kamo said. So you take your 30 degrees Celsius, okay, and the first thing you do is you times it by 1,8, because they said over here you must divide by 1,8. So we want to work backwards now to go from Celsius to Fahrenheit. We've got to do the opposite operation, okay? So we would have to times by 1,8, okay? Someone says do that first, and then add on 32. All right, so let's see what we get. I'm going to use brackets times 1.8, close the brackets, and add on 32. 86 degrees Fahrenheit. Okay, so we've got an answer here of 86 degrees Fahrenheit. All right, now how can we test if this is true? Well, we can go back to the original formula and plug in the 86. So let's see. So to get degrees Celsius again, which should be 30, let's check. If we take our 86 and we minus 32, and then we divide by 1,8 again, we work backwards the other way now. Let's see what we get. All right, let's do this sum and let's test and see. All right, 86 minus 32 and divide by 1.8. Ah, perfect. Absolutely perfect. Okay, so we can see here that even if they didn't give us the correct formula, they gave us a formula. We're changing the formula, the subject of the formula to suit our needs. All right, right now we can say that degrees Celsius is the subject of this formula. Okay, And what someone did was he changed the formula around to make the degrees Fahrenheit the subject of the formula. Okay, how? Well, by doing the opposite operation. All right, first, instead of divide by 1,8, he multiplied by 1,8, and then instead of minus 32, adding on 32. Okay, so it's the opposite operation of what was there. Now, that skill of changing a formula to suit your need is important, especially in matric. It's good to learn it now so that when you get to matric, you have that skill. All right. For those people who are not sure how to do that, please do not worry. Okay. I said it was a difficult challenge. I wanted to see if you guys could understand that question. Don't worry if you're not getting that question. Okay. But all of the other skills that we've done today, all these other calculations, converting between imperial and metric, you guys should be able to do these. You should be able to understand these now as well. All right. Now, I want to talk quickly about other conversions, okay? Because there are other conversions that aren't imperial or metric, or one might be imperial, or one might be metric, but you don't often see them. Then one of them might be non-imperial or non-metric, okay? For example, you'll see this question often in grade 10 and also in grade 11, but they'll give you a conversion table, and they'll say, for example, that 1 cup is equal to 115 grams. Okay, where will this kind of conversion be useful? I'm sure you guys have seen this before. Where will this kind of conversion be useful? Someone in chat, please tell us. Where do we use this kind of conversion in our day-to-day lives? 1 cup is equal to 115 grams. Okay. Anyone? Where could we use this conversion? Recipes, and Paul. Very good. Baking, very good, Sandy. Yes, baking. Baking, when you cook or bake. Very good. So you guys, what are you guys all telling me that you cook and bake? If you've seen this before, cooking and baking. Huh. We have, oh, that's a, okay, Lindsay's like, no, definitely not. All right, but I'm sure you've seen it on the back of packages, or maybe in a question, an exam, or maybe you've worked with someone in the kitchen and you've dealt with that conversion there. Yes. So this is another conversion. Now, this is not imperial to metric, okay? We can recognize the 115 grams, that's metric, but the 1 cup is definitely not imperial. All right, so we do get conversions. We have to change one thing into another, but again, they have to give you the formula for this, okay? And this would be just the same, for example, if we had, I'm just going to make it up now, all right? So don't shoot me down. Let's say, for example, 1 meter was 115 inches, okay? Let's just pretend for now, all right? It's the same thing, okay? We're just dealing with different units. Here we're dealing with meters and inches, but on the left here, we are dealing with cups and grams, all right? You will do the calculation the same way, but they will have to give you the formula when you're converting from the metric system to some other system. Yes, we do get these funny conversions where it's not imperial, cups, spoons, teaspoons, you often see TSP. For teaspoon, you obviously TVSP. For tablespoon, can anyone else think of any more? I can think of cups, teaspoons, tablespoons. Can you guys think of any more? You guys think of any more conversions that they use in baking? I can just think of cups, teaspoons, and tablespoons. What can you guys come up with? I don't think there are sauces. I'm not very good in the kitchen myself, but I've seen cups, teaspoons, and tablespoons when it comes to recipes. Okay, and this is why learning about conversions is very important, because one person might be talking in one system, and then you need to convert into your system that you understand. So we need a conversion, all right? And these conversion formulae are given to you in the exam. They have to give them to you. You're not supposed to know how many grams there are in 1 cup. Okay, so yes, we do get other conversions besides imperial to metric, but often you're going to get questions that are dealing with mostly imperial and metric conversions. When dealing with things like distance, mass, volume, often there are conversions between imperial and metric, and even temperature as well. All right, don't be scared of the temperature formula, the imperial metric temperature formula. They have to give it to you. You just need to know where to put the numbers and let the calculator do the work for you. Okay, I hope everyone's okay and understands that. This section will be tested in the quiz. It's going to come up on Thursday, so there'll be a couple of questions on these conversions, and you'll see them in the quiz. It's just a few marks, and then tomorrow we're going to go and do time. We're going to talk about conversions within the time system. Okay, so if we log on Thursday again, when we see you guys all again, and I hope we see you all again. It's been real awesome sharing this time with you and working with you guys, and I'm glad you guys did some work with us as well. When we see you again on Thursday, you'll be doing conversions within the time system. All right.
I think
Yes.
before everybody logs off, I'm just quickly going to share a poll that we would like for you to take for us. It's not yet time.
Yes, after every lesson, we ask you guys to take a quick poll. Okay. We ask you to take a poll for us. Just let us know and give us some feedback on how the lesson went. If there are any changes that we need to make. But I hope everyone enjoyed the lesson. And grade 10s, I hope you learned something today. Grade 11s, I hope I challenged you with some of these questions. I know this last one was difficult. Grade 10s, don't lose focus. You stay focused. If you can try these grade 11 questions, I promise you're going to get some really good marks at the end of the year. Okay, so grade 10s, you hang in there. Sometimes it will be challenging when you see some of these questions, but if you can tackle them, take them on, and give them your best shot, I know for a fact that you guys will definitely improve your marks towards the end of the year.